Hi everyone! Today we will be converting from radians to degrees. Here's today's FLT. Given an angle, I will be able to convert from radians to degrees. So in the previous lesson, we looked at how to convert from degrees to radians. Today we'll be going in the opposite direction. So just as a reminder, converting is like going from inches to feet or like inches to centimeters, where the measures are the same, we're just writing them differently. And if you haven't had a chance to watch Converting Degrees to Radians, please try to watch that lesson first. Alright, so last time we talked about our conversion factor. 1 pi radian equals 180 degrees. So both radians and degrees are ways to measure angles, and so having 1 pi radian is the same thing as having 180 degrees. So using this conversion factor, let's look at some examples. Here's our first example. Convert the angle from radians to degrees. We have pi over 3. So remember, whenever you see a pi, just automatically think that the unit is in radians. So we have pi over 3 radians, and we'll convert that into degrees. There's actually two methods, so let me go over both. For method 1, we set up a t-chart similar to last time. We have pi radians over 3, and on the right side, we include our conversion factor. So we want to go from radians, which goes in the bottom, and end up with degrees, which is written at the top. What's the conversion factor? 1 pi radians equals 180 degrees. And so from here, notice how the radians cancel out, and so do the pi measures. So we're simply left with 180 degrees over 3. And 180 divided by 3 equals 60. So pi over 3 radians is the same thing as 60 degrees. So this was method 1. This one's a little lengthier, but it always works. Now let's take a look at method 2. Method 2 is much simpler, but it doesn't always work. So in later examples, we'll see when this method does not work. So for method 2, we write out what we have. So we have pi radians over 3. But we know that pi radians is the same thing as 180 degrees. So we can simply replace this part with 180 degrees. So right here, I just replaced pi radians with 180 degrees. And then we have 180 degrees over 3, which again equals 60 degrees. So regardless of which method you use, you get the same answer. When you can use both methods, it's probably easier to use method 2. And then let's look at which quadrant this angle lies in. So 60 degrees lies in quadrant 1, the first quadrant. So this means that pi over 3, which is the same thing as 60 degrees just written differently, also lies in quadrant 1. Up next, we have pi over 4 radians, and we'll be converting this into degrees. So let's go ahead and try both methods. We'll start off by using method 1. So this is the method using the t-chart. We have pi radians, I'll just shorten it to rad, over 4. And on the right side, we include the conversion factor. We're going from radians to degrees. We know that 1 pi radian equals 180 degrees. What cancels out? The radian units and also pi. So here we are left with 180 degrees over 4. And 180 divided by 4 equals 45. So we have 45 degrees. Now let's try the same example, but using the other method, method 2. This is where we replace pi radian with 180 degrees. So we have pi radians over 4. And we know that pi radians converts to 180 degrees. So let's just replace it. We have 180 degrees divided by 4, which equals 45 degrees. So pi over 4 radians is the same thing as 45 degrees. And notice how the angle lies in quadrant 1. For our next example, we're going to convert 3 pi over 2 into degrees. So again, I'm going to write out both methods. When you're doing your own practice problems, you can choose the one that you feel more comfortable with. Well, as long as you can use both methods. Okay, so I'm setting up my t-chart. Definitely let me know if you have questions about this step. And notice here, the radians cancel out, and so does pi. So we're left with 3 times 180 degrees over 2. And there's a few ways you can approach this. Here's the first way. We know that 3 times 180 is 540. So we can write this as 540 degrees over 2, which is 270 degrees. But there's another way where you can reduce beforehand. So at this step right here, you can notice that you can divide both numerator and denominator by 2. And you simply get 3 times 90 degrees, which equals 270 degrees. So either way. And then now let's try method 2. So this is where we simply replace pi radians with 180 degrees. So we have 3 pi radian over 2. But this pi radian part becomes 180 degrees. So we have 3 times 180 degrees over 2. And the following steps are similar to what we just did in method 1. And we get 270 degrees. And let's take a look at where this lies on the quadrant system. Notice how 270 degrees is right in between quadrant 3 and quadrant 4. So regardless of whether it's written as 270 degrees or 3 pi over 2 radians, the angle is right here. Okay, now let's take a look at example 4. We have something that looks a little different compared to the previous examples. So we're going to convert 6 radians into degrees. Notice for this example, there is no pi value, so we cannot use method 2. So we can only use method 1 if we don't see a pi character. So method 1 is the t-chart. We start with 6 radians, and we're going to convert using the conversion factor. So 1 pi radian equals 180 degrees. The radians cancel out, but everything else just stays. So we get 6 times 180 degrees over pi. And this equals, so let's see, 6 times 180 is 1080 degrees over pi. And in your calculator, you're going to plug in 1080 divided by pi. And let me know if you need help finding that pi symbol in your calculator. So don't use like 3.14, use the actual pi symbol. And then if you plug it in, you're not going to get an exact answer. It's going to be like an endless decimal. 343.774, and it keeps going. But usually the problem will just ask you to round to the nearest tenth. So in this case, we would have to round up. Oh, and don't forget the degree symbol. So we find that 6 radians is approximately equal to 343.8 degrees, almost a full circle. And one thing I want you to remember is the difference between 1 pi radian versus simply pi. So 1 pi radians equals 180 degrees, but when we're simply looking at pi is actually a value 3.14, and it just keeps going. So for example 5, we're going to convert 3.1 radians to degrees. Again, here we can only use method 1 because there is no pi. So I'm setting up my t-chart here. And it's the same steps even if we're working with like a decimal radian, like 3.1 radians. Notice here the radians cancel out. So we have 3.1 times 180 degrees divided by pi. And then we use our calculator here. 3.1 times 180 degrees would be 558 degrees, and then over pi. And then again, make sure you're using the actual pi symbol when you're plugging this into the calculator. Your answer should look something like this, 177.616, and then keeps going. But we're just rounding to the nearest tenth. In this case, we're rounding down. So we get 177.6 degrees. Notice how it's almost half a circle, but not quite. And for our last example, we'll be converting -5 radians to degrees. Notice how we have a negative, but the steps are still the same. And we'll talk a little more about what it means to have a negative radian in future lessons. So here I'm setting up my t-chart. Again, 1 pi radian converts to 180 degrees. The radians cancel out, and we get -5 times 180 degrees over pi. -5 times 180 is -900, so we have -900 degrees over pi. And if we plug this into our calculator, we would get the following, -286.478, and it keeps going, but we're just going to round to the nearest tenth. In this case, we would round up, so we get -286.5 degrees. So -5 radians is the same thing as approximately -286.5 degrees. And again, we'll talk a little more about what it means to have a negative angle in future lessons. So just as a quick review, remember this conversion factor, 1 pi radian equals 180 degrees. Today we use this conversion factor to convert from radians to degrees. Great job today, and please remember to submit your notes on Canvas.